In this video, we're going to look at how to use scripts to automate your statistical analysis in ChemStat. The word script is kind of a misnomer. It's not really a script because you don't actually write anything. It's all point and click. You might think of it as a batch process. Here in the workbook view, I'm on the Scripts tab, and to create a new script, I just right-click and select New Script. Here are all of the parameters available in my data set. I double-click the parameters to add them to the script, so only the selected parameters will be run. Here are all of the available commands, reports, and graphs that you can create in ChemStat, and they are further divided by the available confidence limit, such as the probability plots, which can be run at 95% or 99% confidence. So let's just do a probability plot graph. I'll do one at 95 and one at 99. So this script is going to generate two probability plots for two parameters. From the right click, I'm going to execute the script. And it ran the script just that fast. All of the results of the script are added to the workbook. So I had two different probability plots at two different parameters. I can double click on the item in the workbook to view it. So here's my 95%, and there's my 99%. Let's look at a script with a data transformation. From the right click menu, I'm going to select New Script. I give the script a name. I'm going to add some parameters. I'm going to do a basic statistics report. Then I'm going to find a data transformation. I'm going to do a log transformation. And then I'm going to do a basic statistics report. I'm going to execute the script. Now let's look at the workbook. Here are my basic statistics reports for all the parameters, and I have one with the original data and one with the log transformation. Let's do another more sophisticated script. I'm going to do a script just on cadmium. Let's add an outlier test. We'll do Dixon's test for outliers and Rosner's test for outliers. And let's do a normality test. Let's do this test for normality. And let's try a parametric test. Let's do an individual well comparison with the parametric t-test at 99%. You'll note that the Dixon's test was inappropriate in this particular case, but the Rosner's test succeeded. This is based on the number of sampling points in the test. If we look at the icon, the Dixon's test is yellow, and that means it was an inappropriate test. If I open that test, you can see that this test can only be run on between 3 and 25 measurements. And if I go to the advisor window, you'll see that it says this data set has 29 samples for the selected parameter. The method is suitable for 3 to 25 samples only. So that is why the Dixon's test failed. But the Rosner's test is an appropriate alternative for that. And we can see from that that measurement MW9 is an outlier. I can also look at my parametric t-test. I can see that MW9 had elevated concentrations. Now let's go to the Summary tab. I can see that for cadmium, MW9 was statistically significant. Let's look at how you can automatically exclude outliers from your data set. I'm just going to limit it to cadmium in this case. I'm going to select automatic analysis commands. These are all the commands that are available to just do an automatic analysis. I'm going to automatically exclude outliers. So this ran Rosner's test for outliers because it picked the best test for the data set. And we can see that MW9 was an outlier for cadmium. From the distribution menu, I can select outlier list, and this lists all of the outliers in your data set. It's not just that these are outliers. They have been removed from the data set and excluded from any further statistical analysis. This happened automatically when we ran the script that automatically excluded outliers. From the options menu, I can select Add Remove Samples. I'm going to select MW9, and you can see that MW9 lists cadmium as an outlier. So it has been excluded from any further statistical analysis. I'm going to add it back in by clicking the Restore button. Now when I look at my outlier list, MW9 is no longer listed. Now let's look at a more sophisticated automated analysis. I'm going to select some parameters. I'm going to do an automatic analysis. I'm going to do an automatic intra-well comparison. I'm going to transform my data. And then I'm going to do another automatic intra-well comparison. And I'm going to add an automatic test of normality. The important point to understand with these automated tests is that ChemStat is going to select the best possible test out of that category based on your data. For example, we selected automated intra-well comparison, but there are many intra-well comparisons available. ChemStat is going to choose the most appropriate intra-well comparison for the test data. Let's look at the results. So for each well and for each parameter, I have a non-parametric prediction limit because that was determined to be the most suitable test. And there was no statistical significance in this case. Then I ran the Shapiro-Francia test of normality. And this is still on the original data. I did a probability plot. And now I've transformed my data and did another normality test and a probability plot. And that concludes the analysis for cobalt. Then I repeated those steps again for the other parameters. Let's look at my summary table. And we found that for those parameters, we had one statistical significance, MW4, for chromium. Thanks for watching. That's it for this video on how to use scripts in ChemStat.